Welcome to the deep dive. Today, we're heading back to Argentina, late Cretaceous period, to look at a really big dinosaur, Bonatitan.
That's right.
We've got the Wikipedia page pulled up. That's our main source here.
Inkta.
And our, let's say, mission is to figure out what makes this particular Titanosaur stand out. What's its story?
Absolutely. And Bonatitan is, well, it's more than just another huge sauropod. It gives us some real clues about the titanosaurs, these massive plant eaters that were really dominant right at the end of the dinosaur age.
Okay, so context is key.
Exactly. To really get Bonatitan, we need to see where it fits in the bigger picture, the tree of life.
Right, let's map it out then. We always start broad, domain eukaryota, basically everything with complex cells, so not bacteria or archaea.
Correct. Then kingdom Animalia. It moves, eats, grows, definitely an animal.
Okay, phallum chordata. That means it had a notochord at some point, like a precursor to a spine.
Precisely. A fundamental feature for vertebrates and their relatives. Then we get to the exciting part. Clade Dinosauria. Proper dinosaurs.
The main event. And within that, Clade Saurischia. These are the lizard-hipped ones, although that name's a bit tricky sometimes.
It is a bit misleading now, yeah. It's based on the ancestral hip structure. Sauropods like Bonatitan are Saurischians, even though their hips evolved differently later on. It sticks historically.
Gotcha. Next is Clade Sauropodomorpha. Now we're talking long necks, clant eaters, the classic sort of giant dinosaur shape.
And within that group, we find the true giants. Clade Sauropoda, the largest land animals ever.
Seriously massive creatures.
And Bonatitan belongs even deeper within Sauropoda. First, Clade Macronaria. These often had large nasal openings, maybe related to breathing or thermoregulation, and sort of peg-like teeth.
Interesting. And then Clade Titanosauria, the dominant sauropods of the late Cretaceous, especially in the southern hemisphere, sometimes armored, sometimes not.
Right. The armor osteoderms wasn't universal despite the name Titanosaur. Okay, getting closer now. Family Saltasauridae.
Saltasauridae, what's distinctive about this family?
They're a key titanosaur group, often a bit smaller than some of the really enormous titanosaurs, relatively speaking. And yes, some, like Saltasaurus itself, definitely had those bony osteoderms for protection.
Okay, and Bonatitan is in the subfamily Saltasaurinae.
Correct. And finally, that brings us down to the genus Bonatitan and the specific species Bonatitan regi.
Bonatitan regi, that's the full scientific name. Martinelli and Forsythe, 2004. That's its unique ID in the system.
Exactly. And like you said, named in 2004. The fossils themselves come from the Allen Formation in Argentina, which is late Cretaceous, a really productive geological layer for dinosaur fossils.
And the names Regi and Bonatitan, they mean something, don't they? I saw the specific name Regi honors Osvaldo Reg.
Yes, Osvaldo Reg was a really foundational figure in Argentinian paleontology, a major influence.
And Bonatitan.
That one's a double honor. It recognizes both Reg and Jose Fernando Bonaparte, another absolute giant in South American paleontology. So the name itself is packed with history.
That's actually really cool, embedding the scientific heritage right there. Okay, let's talk fossils. The holotype that's the original specimen used to define the species, right? MACN POV RN 821. Sounds like it was initially a bit of a mix.
Yeah, the first description was based on several pieces. A brain case, which is obviously really important for understanding the head, but also some tail vertebrae and various limb bones.
Okay, sounds pretty standard. But then things changed.
They did. As paleontologists do, they re-examined the evidence. In 2014, Salgado and his colleagues published a study where they amended the holotype.
Amended, so they revised the definition.
Exactly. They looked closely at the size and proportions of all those bones cataloged under MESEN PV RN 821. And they concluded that the limb bones and vertebrae didn't quite match the brain case. They seemed to be from a potentially different, perhaps larger or just differently proportioned individual.
Ah, okay. So they decided only the brain case should be the official holotype.
Precisely. The brain case is now the definitive reference point, the gold standard, if you like, for Bonatitan regi. The other bones are still considered Bonatitan, probably, but are cataloged separately now as belonging to at least one other individual.
That makes sense. You want your defining specimen to be unambiguous.
Absolutely crucial for accurate science, avoids mixing traits from multiple animals.
Okay, so with that clarified, where does Bonatitan sit within its family, the Saltasauridae? There's a cladogram mentioned from Navarro and others in 2022 that's like a family tree. showing relationships.
Yep, cladograms show branching patterns based on shared features. This one places Bonatitan firmly within the Saltasaurinae subfamily.
And who are its neighbors in that subfamily?
You see it grouped with some well-known names and some perhaps less familiar ones. There's Alamosaurus from North America, interestingly, and then South American forms like Bonatitan, Iberania, and Ricasa.
Okay. And there's another subgroup within that, Saltasaurinae.
Right, a tribe within the subfamily. That includes Nuconsaurus, another specimen known just by its number for now, MACNPV-AG528, and the famous Saltasaurus itself, which gives the whole family and subfamily their names.
So Bonatitan is kind of a cousin to Saltasaurus and Nuconsaurus, but maybe not quite as close as they are to each other.
That's what this particular analysis suggests, yes. It shows Bonatitan branching off slightly earlier than the core Saltasaurinae group. And it's shown as distinct from the Opisthecoelacoidinae group, which includes dinosaurs like Opisthecoelacodia and Namegtosaurus found further afield, like in Mongolia.
It really highlights how widespread and diverse these titanosaurs were. And these relationships, they're not set in stone, are they? They get updated.
Constantly. New fossils, new ways to analyze the data. This tree is always, potentially growing new branches or having old ones rearranged. It's dynamic.
Okay, let's pin down the when and where. Temporal range.
The fossils date to the late Campanian through early Maastrichtian stages.
So we're talking very late Cretaceous, maybe, around 72 to 68 million years ago, roughly?
Yeah.
Right near the end.
Exactly. The final stretch before the asteroid impact.
And the location is specifically the Allen Formation in Argentina.
Yes, Rio Negro province. That formation is a crucial window into that specific time and place in Patagonia. Finding Bonatitan there helps us build a picture of that ecosystem.
It sounds like a hotspot for discoveries.
It really is. Lots of important finds have come from the Allen Formation.
Now, for anyone listening who wants to dig even deeper after this, the Wikipedia page lists some external links.
Yeah, they're good resources. DinoBase, FossilWorks, DinoData, DinoChecker. There's also a blog mentioned, Equatorial Minnesota. These often have more technical details, images, maybe links to papers.
Great starting points for further research.
Definitely worth checking out if you're really keen.
Okay, so let's recap Bonatitan. It's a titanosaurian sauropod, lived in Argentina right at the end of the Cretaceous.
Check.
Its name is a cool tribute to paleontologists Bonaparte and Reg. The original fossil collection was refined, so now the brain case is the key holotype specimen.
That's right, a crucial refinement.
And phylogenetically, it sits within the Saltasauridae family, specifically the Saltasaurinae subfamily, related to, but distinct from Saltasaurus itself.
You've got it. That sums up the key points pretty well. It's another important data point for understanding Titanosaur diversity in South America.
Which leads us to a final thought to leave you with. We've seen how our understanding of just the initial Bonatutan fossils has been adjusted over time. Considering the Allen Formation keeps yielding new discoveries, what else might be waiting out there? What future finds could reshape our view of not just Bonatutan, but the whole ecosystem and the intricate relationships between these incredible late Cretaceous giants?
It's exciting to think about what might come next.
Definitely something to ponder. Thanks for joining us on this deep dive.